Yeah, it's nice to be here again. So, and today's topic is on biased data and asset. So to start with, I will start with a small icebreaker. I think you see a image in the right. I want you to guess and tell how many triangles are here. Yes,
Students, please respond.
11, bro.
11. Anything else? Any other?
In
Any other
chat,
Zero.
answers?
in chat,
Zero.
someone has written 8.
8. Okay. 1. So I think somebody has still told the right answer. The right answer is 0. So what you see here is some tilted V shapes and some Pac-Man shapes. So that's all you see here. So there is no real triangle here. If you hide all the black objects there, then there's nothing. It's all white. Okay. So yeah, let's get into the topic. So here is what I'm going to cover today. So we'll start with a quick introduction on data and different aspects of data and why do we need data. And then we'll look into how organizations are looking into data, how they are treating it. And then we can deep dive into some of the technical areas and then the end-to-end process on how it works in business. And in the end, the most important part of for you, I would say, the career in data analytics. Okay, so that's the agenda for today. So let's start with the introduction. Okay, so data. So this word is often being pronounced. Okay, so it has seen a tremendous growth in the uh, recent times. Okay, so where there's a lot of scope, even in terms of job, even in terms of how business are looking into it. So something that's not seen decade or 2 decades back, there's a lot of buzz around this word. Okay, so that's what we are going to understand in the beginning. What's that all about? What people are trying to achieve? Okay, so before 21st century, right? Data is seen primarily as liability. So liability in the sense something that they have to just archive and store to meet the compliance on legal requirements. Okay, they are not really thinking about data to be stored and uh, they're not thinking about getting revenue out of data, okay, on whatever they store. So it's primarily seen as a liability 2 decades back. But how things changed, okay, why data is very important nowadays, why it's considered very important, what has changed in recent times, and what has made data a very precious commodity. Okay, so this is the perspective that got added in early 21st century. Okay, this is something that's stated by one person, but there are a lot of different statements and researches around it. So let me read it out. So the goal is to turn data into information and information into insight. So this is the perspective of how businesses started looking at data. Okay, so they wanted to they and another reason for it is the uh, increasing computation power. Okay, so now we have very good machines, which we didn't have 2 decades back. So they were able to do something. They statistics and computer science. Okay, so a lot of things happened, which turned out to be an evolution. Okay, so and people started understanding the value of data and how data can contribute. And okay, so I just want to cite a good example, good success story before uh, we get into the further things, further details. Okay, so you all must be knowing Amazon and you know how big e-commerce site it is. Okay, so you didn't believe that approximately, or not approximately, on an average, their product price gets changed 2.5 million times daily. Okay, it's some number that is captured. On an average, they are changing their product prices as a whole 2.5 million times daily. and the cost of average product is changing every 10 minutes. Okay, so again, it's as a whole. One product, the price might change 100 times a day, and another product maybe 2 times a day. But on average, the cost of average product is shifting every 10 minutes. Okay, so all this is achieved through data. Okay, they have the data of how many people are looking to buy their products on a given day, or what's the availability in their inventory, and how's the demand. Okay, so they were able to analyze all these things and in a real time. That's most important. Speed to market is very, very important nowadays. Okay, so they're able to do it in real time, and they are able to adjust the prices based on yeah, how the trend is. Okay, and you might be seeing the Amazon deals and everything. All those are driven by data. It's not someone who is going and adding something in the deal for the day. It's all controlled by data. Okay, so that's a good example to cite. Okay, so some other interesting stats. So the data that we are okay, so what we are collecting every year nowadays, it's much more than what was existing for millions of years. Okay, so that in the last 3 years alone, more than 90% of bad data has been created in the last 3 years alone. Okay, those are some interesting stats, and it's always going to increase. Okay, and now the question arises. Okay, what's that people are doing today? Okay, so what exactly is this data that they are collecting? Okay, that they haven't done before, because the numbers that you see here, it's quite big. Okay, so let me let me put it through some simple example that all of us can understand. Okay, so we look at two pictures here, and I have a question for you. Okay, so the sales in the juice stall wasn't good yesterday as it is today. Okay, so today the sales is comparatively better, and you see two pictures, one captured in the juice stall yesterday and another captured in the juice stall today. Okay, so can someone tell what could be the reason for this?
Due to weather. Yesterday it was rainy, so no one could buy, and today is it good weather, so it could, so the
Okay,
sale would go up.
yes. Okay, that's what exactly has happened there. Okay, so yesterday it was raining, and the rain has impacted the sales of the juice. Okay, or the cool drinks, whatever you say. So 20 years back, if I would say this right, I'll tell you what data businesses will collect. They'll put a number called date. Okay, they'll put a date, and they'll say that this is the this is the sales on that particular day, and again another date, and that's the sales on that particular day. Okay, things have changed slightly now. Okay, now people started also capturing the temperature, humidity, whether it rained or not. Okay, so they are interested in much more attributes. Okay, than what they were collecting long back. And if I were to tell what it brings to the table, uh, earlier they'll not be able to look back at the history and understand why exactly this happened. Okay, that's another thing. And again, they were not able to be prepared for certain things in future. Uh, they okay. This is a very simple example where people can at least suggest something, but let's take a very complex example where things becomes really complicated. Whether if they don't capture a lot of meta attributes like weather, temperature, political scenes, and everything, it becomes a little tougher. So let's come back to this example itself. So now when you capture the weather, temperature, and everything, you have all the readings. And okay, so you collect 2 days data, you collect a year's data, you collect 2 years data. Now you understand the pattern. The weather is increasing, or the temperature is increasing, the sales of juice is going up. Okay, so the temperature is decreasing, maybe the sale of coffee is going up. Okay, so they now have a plan and on where exactly the production should need to be. what exactly they need to produce on a given day, okay, based on the temperature. So on a cloudy day, they have a plan. Okay. On a windy day, they have a plan. Okay. So that's that's the new perspective of how people started looking at data, and they started collecting a lot of data, okay, which could indirectly make a lot of sense. Is it clear? Yes. Would
Yes,
like
sir.
to.
Yes.
Okay. Sounds good. So yeah, how many of you have seen this?
Yes.
Ha-
Every time in
okay.
websites.
You see it every time. It's not a bad thing. Okay. So it's not a bad thing to accept cookies in a trustable website. Okay. So and but there is a yeah, because there is some good part to it as well, because um, I'll tell you what people do. Okay, so by allowing cookies, you are even agreeing, saying that okay, they are tracking when exactly you visited the site. Okay, when exactly you're visiting the site again. Okay, so all this information, uh, the owner of the website is able to capture. Okay, so and one point is they can personalize things for you on how exactly you want things, because they can find similar users like you and what they did, and they can suggest the same to you. Okay, and in the background they're collecting a lot of behavioral data about yourself. Okay, so it's not just data that they can directly go and collect. Okay, they're expecting a lot of data, so they're collecting behavioral data as well. That's what I wanted to insist. Okay, when it comes to behavioral data, it's quite a large volume that they will collect. Okay, and end of the day, they keep all these to analyze what can be given to you. Okay, so they find a lot of similar users like you, and they know what they did. Okay, and they give things accordingly to you. Okay, and one more interesting aspect is the digital footprints that you leave. You log into your Facebook. It's not it's not that you are just giving a name and such things. You are liking a lot of things. Okay, they understand what images you like. Okay, or what pages you like. Okay, because a lot of uh, there is no manual process there. There is no manual check involved, but still their system is efficient enough to understand what kind of pictures you like, or what kind of pictures that you react to, or what post do you command, okay, or what pages you like. Okay, so and these data is being sold to, let's say if I'm a, um, what I would say, so if I'm owning a shop and I'm selling something, okay, if I and now I can go and market in Facebook, where where I can target only people who like my items, who like my items. So these actions, uh, okay, so all the digital footprints that you leave, it's not only this, there are quite a lot of examples that I can cite, but I'm giving a simple example that will be more relevant. So it's quite a lot of information that is collected at the end of the day. So that's all with the introduction. Any questions? Anyone?
No, sir.
Okay. Uh, anyone? Yeah. Okay. So if not, then we'll proceed. Okay, so now let's discuss on how exactly organizations are doing things. Okay. So what is the approach? So here are the three different phases. You can see it circled below. So the initial phase is to explore in a sense. Sometimes you collect a lot of data without even knowing what value it's going to add. Okay, if you see something, bring it in. Okay, that's how people are looking at things. Okay, so they bring it in, they see if it is correlating to something. Okay, then they keep it for a long time. Okay, but initially bring everything. Okay, so it's uh, yeah, so it's called as exploratory analysis actually. So people bring everything, okay, and then you discover things. Okay, so discovering things in the sense understanding what's happening. Okay, what's the correlation with it, what exactly is going there. Okay, and then you uh, use it for your future predictions. Okay, so this is a simple formula that every organizations will have. So again, I would like to cite another example. Okay, so let's assume that you're applying for a car insurance policy. Okay, so you provide some details about yourself and your vehicle to the insurer. Okay, so maybe your vehicle number, what's the model, make, and about you, your personal details, address, and a lot of things. Okay, so now when you provide these details, right, now these insurer, okay, so they are going to collect a lot of additional details about you from some third party vendors. Okay, so credit score, maybe from CIBIL, there is experience. So there are a lot of providers. Okay, so from where they collect a lot of data about your vehicle again, whether you have any past violations on the road, okay, or whether you as a person has any uh, road violations. Okay, so all the history and everything, and it's all captured from third party vendors. Okay, where they have enough data. Okay, and that's again another set of data that's getting added. So now they will process your application. Okay, so your request or whatever you submitted, and now there are several softwares or applications that are involved uh, in rating your application. Okay, so there are some internal applications. So these again will generate a lot of data. So it's all based on this. You get some codes to pick from. Okay, so just understand you might be giving only let's assume 10 KB of data, okay, 10 kilobytes data, but maybe the organization by the end of this process have 10 MB data about you, okay, about you or for you. Okay, so it has increased 10 times. Okay, so that's where data is growing. Okay, so with this growing volume of data, right, then there is a increasing need to handle them, um, store it in a right way. Okay, and okay, so let's talk about the okay. So now we know that okay, data is somewhere considered as an asset. Okay, so you collect all this data, and I think you hope that you all understand a little bit of value that data is adding now. Okay, so now it's an asset. Okay, so often companies are handicapped where they cannot really uh, make it in a useful way. Okay, sometimes they have less manpower or less resource or less technological capabilities. Okay, so and at that time, these assets are considered as fixed assets. Okay, where there is not really any turnaround made using the data. Okay, but current assets is where you have all the capabilities, potential to analyze this data and predict your future needs. Okay, so how exactly do you convert your fixed assets to current assets? Okay, so that's where there is a growing need today. Okay, so some of the important points that I would like to cite is, so the need is to bring all the data together. Okay, so your data resides in many transactional systems. Okay, so let's take the example that I cited earlier, where you apply for a car insurance policy. Okay, you apply somewhere. Okay, that stays somewhere, and you order through some third party. They send it back somewhere, and then again your process is okay. Then there is some rating engines and rules engine that's involved, which validates with some applications. So all this data is in different transactional systems. Okay, these different areas are called as transactional systems. Okay, so all your data is residing in different transaction systems, and you should bring all this data together in a single place. Okay, so that's the first challenge. Okay, and the second challenge would be, now you have brought all the data to a single system, and not all this data is easily readable. Okay, so readable in the sense something that you can query with normal SQL language. Okay, so if it is in rows and columns, it's readable for everyone. Okay, so but in reality, data is not directly readable. Okay, so I think you must be aware of file formats like XML, JSON, fixer length. That's how most of the data start from its root. Okay, once when an application is generating something, they are putting together everything in the form of an XML and sending it across. When you order something from third party, or mostly it's happening through API calls or anything, and whatever response you get, it's mostly XML or JSONs. So these data are unstructured or semi-structured, where it's not readable directly. So there should be some amount of work involved to make it in a readable format. Okay, and then the next challenge is you make it readable, but you want to store a large volume of data. Okay, so where you should have big storage capacities, and it's important that you store efficiently and don't add any redundancy. Okay, and then the next challenge comes where you want to, now you've stored the data, you want to get insights out of data and then predict the future needs. So that's where there is a growing need nowadays, and at least for next several years. Okay, this is going to continue and it's just going to increase. Okay, and okay, so this is a high level picture of some technical aspect of how things are being done. Okay, we looked into earlier where, okay, so you get the information out of data, and then data is converted to informations and then into insights. Okay, so this is how it is. So you bring all the data into a single place called data warehouse, and from there you logically separate different subject areas that you have, and then you do all the analytics that you want. Okay, so this is the overall flow, okay, in a technical level. And let's look into some of the significance. So this is just whatever I told earlier, citing different examples and just have put it together. So data, you can analyze how you're standing in the market. Okay, how's the market like? What's the trend? Where exactly is the demand? Okay, so all that can be understood using data. And then it improves your consumer database. Okay, you exactly know these are the people who are interested in my product. Okay, so, and which also helps you to scale your business up. Okay, you know that these are the type of people who are interested. So if there is a place where there are a lot of such geographic people or people who are living, then let me have my store open there as well. Okay, so, and then it also helps in different marketing strategies. Okay, so you do something, there is a big turnaround. You do something else, there's a less turnaround. So now you exactly know what exactly to be done. Okay, so all these are done through data. And next one is also something that I cited earlier. It allows for greater personalization. Okay, when they're marketing, right before they are marketing, they know what exactly you want. Okay, and they are bringing to you only what you want. Okay, so you buy one product, they are able to suggest 10 other products that you can buy. Okay, so that's all done through data. Okay, any questions so far before we get into some of the core technical concepts? I think everyone is clear, right? Can I hear a couple of yes?
Yes, sir.
Yes, I think I'm hearing only from the same person again and again. Anything, any clarifications that needs to be made? Any questions? Okay, sounds good. Let's proceed into some of the core technical areas. Okay, so all of these terms should be a little familiar to you. Okay, big data, data lake, data warehousing, data wrangling, data science, data visualization. Okay, so let me explain what each of them are. Okay, so let's start with big data. So, okay, so I already told that data that come in. Okay, so there is a large volume of data that's coming in, and there is a there are different types of data. Okay, some are in XML format, some are in CSV format, some are in JSON format, and um, videos, a lot of different types of data, a variety of data. So that's what you see here: variety, volume, and the velocity. Okay, data is coming real time or near real time. Okay, or it is even coming as periodic or batch. Okay, but it's quite a lot of data that's coming in, and you need efficient systems which can work parallelly, okay, to meet out your needs. Okay, so uh, there's a concept called distributed processing in big data. I don't want to dig too much deep. So there is Hadoop ecosystem, and then you have a framework called Spark. Okay, all of these are very much involved when you speak about big data. Okay, so they are the core ideologies behind, are the frameworks or technologies behind big data, I would say. Okay, Hadoop, Spark, Hive, okay, these things. So how they work is they work on a distributed fashion. Okay, you have certain systems. Let's say you have 5 machines which are computationally very good. Okay, you make them work together for your need. Okay, you want to process a 5 gigs of data. So you run a Spark program on top of those in a distributed fashion. And now the work is distributed. Okay, now the work is distributed and you collect all the results together. Okay, so the need arises where you need to do some processing. Your data is not readable initially, so you want to do some processing. There is some computation required to transform the data to a readable format. Okay, so that's where this technology called big data is widely used. Okay, and next thing is data lake. Okay, so again, this is dealing with unstructured data. Okay, a lot of unstructured data, and again, real-time data and everything. But the one difference I would say is in big data, the concept called big data, you process them, you get the data, you process them, and you store it in a different place. But um, people are finding a way there where not every data needs to be processed. Okay, they can be read as it is. Okay, so let's say if you have a JSON, uh, JSON has a schema to it. Okay, JSON has uh, it has a structure and a schema. Okay, so all you want to understand is what exactly is the schema of this. Okay, and you catalog it. Okay, so it's called as a, people call it as metadata or schema. So you catalog all the things. Now people know that this is what exactly is there in the data. It's pretty much like saying that, okay, looking at a cover, okay, a cover of a chocolate, you can say that what flavor it's going to be. Okay, so, and you can understand a lot of things whether it's eatable or not. Okay, so in the same way, this schema or whatever that's being understood out of the data, it's all put as a catalog, and people can refer this catalog to query. Okay, so data is not really converted to a relational format in the, okay, deep inside it's still as files, maybe JSON files, but this catalog or the schema which you have developed in the top of it will allow people to query the data in a relational format. Okay, so unless you visualize it, this could be a little tricky to understand, but end of the day, the concept is less processing. Okay, because there is a lot of data coming in again. Okay, so you can do a lot of processing again. As for some needs, you don't really have to do a lot of processing where you just create the metadata on top of the data, and using this metadata you query it. So some of the supporting tools, to an extent it's also done in Hive, and let's say in AWS platform there is something called Glue, and which facilitates this. So there are a lot of different ways data lake, and even Snowflakes offers something. Okay, so yeah, that's all about data lake. And the next big concept is data warehousing. Okay, so data warehousing. So now you have a lot of data. Okay, you put it in a relational format. You want to store it in an efficient way. That's where data warehousing comes to picture. Data warehousing has a lot of standards where it allows you to store data in a very, what I would say, very efficient way, avoiding any redundancy. Let me cite an example. Okay, so each of you from your class, okay, who are here, you might be having a roll number or a register number for you. Okay, so you must understand one thing. If it is number, then to store numbers in a database, it takes less memory. Okay, less storage. Sorry, not memory, less storage. Okay, but if you want to store some characters, then it's a lot of storage. Okay, so what is done is only in one place your name is stored, and along with your name a number is given. Okay, but this could be your just student data, I would say. Okay, so in a different place, let's say you have a your score data, okay, your marks and everything. Okay, so there again, in data warehousing, as per data warehousing standards, we don't store your name again there. Instead, we will just okay, put the number or the roll number that is assigned to you, okay, in the other table. So now this is avoiding some redundancy. You want it to be stored in two tables, but end of the day, you are storing it in an efficient way that you store the name and all your personal details somewhere, okay, and along with your name, a number is given, and anywhere else, okay, whatever information that's relevant to you, uh, it's related only through this number. Okay, they're not going to redundantly use your name everywhere. So this is a simple example. Okay, so similarly, there are a lot of other standards. Data warehousing is a concept on its own. It's not a technology, it's a concept. But the concept has a lot of things where it allows you to store data in a very efficient way. And then we have data wrangling. Okay, so data wrangling is again to deal with a lot of different type of data, maybe structured or unstructured, but mostly for ad hoc analysis. Okay, uh, ad hoc analysis in the sense. So let's say, let me tell a very simple example. Uh, you have a store and you have multiple POC machines. Okay, bring it all together and get a quick number of sales. Okay, so something like this. Okay, so or you have different marketing agents who maintain different Excel sheets. You want to bring it all together and generate a report, quick report. Okay, so during all these times, right, data wrangling comes into picture where you do a lot of ad hoc analysis, combining a lot of data. Okay, different sources, you bring it together and you want to do something. And any questions so far? I think I'm going in a, let me know if I'm going in a high pace. Okay, so yeah, let's understand what data science is. I think I gave a lecture a couple of months here on data science too. So data science is the is something that's evolved very recently. Okay, not very recently. It's there for quite some time. Different concepts. Everything is there for quite a lot of time. But the actual need, or it's now when people have really started understanding the value of data science. Okay, or it's now when people have really invested on data science, and there are different reasons for it actually. So data science today, data science works. You need a lot of data. You need history. Okay, so the in the background it works like this. Okay, you know what has happened in the past. You analyze it.
Actually, I have one doubt.
Yeah, please. Yeah, please go ahead. If I'm not wrong, that someone had some doubt, right? Um, if I heard it rightly.
I think he had a network issue. He's not
Oh,
able
okay.
to.
Okay. Cool then. Yeah, we'll address this doubt later. Okay. So yeah. So to talk about data science, initially we need a lot of data. Okay. So let's talk about the other things, whatever we discussed so far. Okay, getting data, pulling data, uh, collecting different kinds of data. So big companies like Google, Amazon, Microsoft, or IBM or whatever. Okay, they were doing it maybe 2 decades back. Okay, they started doing it 2 decades back. Some companies, some let's say some top banking companies or anything like that for matter, they would have started doing it 10 years back. Okay, so all the, some of the companies who are in the mid level, okay, they might have started collecting data only 5 years back. Okay, so and now, okay, so almost everyone is interested in data. Okay, so every other company is storing the data. They are capturing all the details. Okay, now is when these analytical works are really playing a major role. Okay, it's not like people are not doing it in the past. Now there is an increasing need because everyone are looking for it. Okay, and this is one of the hard subjects in the market nowadays. Okay, data science, and the way it works is you have all the historic data. Okay, so let me cite an example. Okay, so all these days there might be some human involvement who are diligently working on something. Okay, they might use their thought process in decision making. Okay, so uh, some human are diligently involved. Okay, they are you. It's all human knowledge that's applied in making some decisions. Okay, whether I should approve this loan or not, whether this insurance policy can be accepted or not. Okay, whether this person is a fraud or not. Okay, there is a lot of human intelligence that is involved, and you have all the history of what these people did. Okay, so this is what you collected as data. Okay, on this particular scenario, this is what they did. In this scenario, this is what they did. And now there are some statistical approaches using which you can say that, okay, these decisions based on this whatever data I have, uh, it is because of increase in the number of this attribute, okay, or increase in number of this attribute, or reduction in number of. So this has really contributed to the decision making. And when you have a lot of data, it becomes easy to predict things. Okay, that's what exactly data science is. Okay, you have a lot of historic data, and at a point, and there might be a lot of human involvement involved. At a point, you would say that thanks for all your efforts. Okay, I have enough data. Okay, now I can do something that can ease up your work. Okay, so that's the flavor behind data science. It's not exactly only human involvement. Sometimes the climate. Okay, so provided the situation, what happened. Okay, so you have all the history. Provided this situation, this is what happened. Okay, providing this change in the law, this is what happened. Okay, so when similar things happen, you are prepared. Okay, so you forecast what the need is. So that's the real flavor behind data science. Okay, and that's why it is a very hard subject now. Okay, so if you look at different aspects here, right, there are different phases. Okay, during certain times certain concepts are really on trend. Okay, and now because everyone has started looking at data, that's why data science is on trend now. Okay, so and it's always going to increase. Maybe this will reach a height in another 3 or 4 years, I'm thinking. Okay, where it will reach a where data science will be on the top. Okay, even in the job market. Okay, so and the last thing here is data visualization. So this is again another interesting part. Okay, so all of whatever we have discussed till now, it's all some technical things. Okay, but let's say if your business owner, okay, or the CEO or your manager, they are okay, they are the ones who are actually interested in looking at what's happening, right? So you cannot explain all these technical stuffs to them. You have to put it in some pictorial representation as charts, graphs, which they can easily visualize and understand. Okay, that's what is called as data visualization. Okay, so you do all this. In the end, if you're not able to project in a proper way, then it's useless. Okay, so that's where data visualization comes into picture. Okay, if you see a trend, you put it in a graph and say that, okay, this is how the trend is. Okay, so yeah, that's all about this and some of the benefits here actually. So I think I must have covered while I am speaking, talking about different things. So benefits of data analytics. So it helps you to anticipate the different needs and be very proactive, and it helps you mitigate the uh, different risks and frauds. Okay, and then okay, then the personalization, whatever we talked about. Okay, it helps you to deliver the right product, okay, to your customers. And yeah, and again the personalization, and then okay, optimizing and improving your customer experience. So again, this is based on the ratings you provide, how you react to the products. Okay, so based on that, businesses are able to adopt and change things on what exactly is the need. Okay, so that's the benefit of data and analytics. Okay, any questions here so far? Not sure if it is understandable or anyone I would like to hear, or maybe I can repeat few things here if it is
It is
not
clear,
registered.
sir.
Okay, yeah, maybe in future we can have more focused sessions. This is pretty much on a high level. Okay, but I want you guys to get an idea, a good picture of this field. Okay, so any other questions? Maybe I can take one or two questions here. No? Anyone? Okay. Let's move ahead. Okay. So the data journey. Okay. So what happens end to end? Okay. We learned about a lot of examples. We learned about a lot of technical areas. But how does this actually fit into the bigger picture? Okay. That's okay. So on a high level, this is what it is: engineering, preparation, analytics. This is the base for your data pipeline. Okay, I think you must have got an idea about this now. Engineering means, okay, so there are roles like data engineer and stuff. That's where they play a major role. Okay, so you have data from different places, you bring it all in, you put it in a relational format or readable way. So that's all your engineering works. And then the preparation. Okay, preparation in the sense, uh, okay, so you want the report or whatever you want to produce, okay, in a particular way. So let's say, uh, okay, so the CEO don't want to know that how exactly how much this person bought or this person bought. A person called A, how much did he purchase? Person called B, how much did he purchase? Okay, or even they're not interested in small detailed things. They want to look at high level things. Okay, so that's where you prepare it, aggregate in the sense, uh, wherever needed, however the reports are required to be, you put the data in a certain way that's on how people want to look at it. Okay, so that's where the preparation part comes in. And then you have analytics. Okay, so if I have to relate with the technologies that we have discussed earlier, in the engineering part, usually the big data, data lake, data wrangling comes into picture, and then in the preparation part, you have the data warehousing, which is mostly into picture, and in the analytics part, that's when data science, data visualization, and sometimes data wrangling is also used here for any ad hoc analysis. Okay, so all that we have learned so far, that's how it fits here. And diving deep, this is the architecture. Okay, so there are different data sources from where you might get the data from. Yeah, again, it might be redundant. Okay, so look at from top to the bottom. Sorry, bottom to top. Okay, so maybe a little bit explained version of what we saw in the previous slide. Okay, so you get data from different sources, you integrate it all together. Okay, and something else I wanted to insist is there is a concept called ETL. Okay, extract, transform, and load. Okay, so that's the process which is used to, once you have data from different sources, that's the process. Data warehousing is where you store it, and you have different source systems, and ETL is the process to take fetch data from different places and load it to the data warehouse. Okay, so ETL means extract, transform, and load. And one of the famous application or tool which is involved in the ETL process is Informatica. Okay, so take any business today operating in the world today. Okay, at least 8 out of 10 will be using Informatica. Okay, that's how powerful that tool is, and I think nothing else could match it until this day. Okay, so there's a tool called Informatica, which is a licensed product, but ETL works are majorly handled with that tool. So along this, there are, okay, so you build the pipeline, and there are a few best practices that also needs to be ensured. Okay, so like fairness, confidentiality, accuracy, and transparency. Okay, so yeah, so whatever you do, okay, so whatever you do, let's say fairness, how to avoid unfair conclusions even if they're true. Okay, so let's say you do something and it should not be only business centric. Okay, somewhere it should be customer centric too. Okay, so you see the price of the petrol rising, somewhere it's getting benefited, but in the other side there is no real benefit, and for them there is no other option. Okay, so it's always important. And okay, those are political things, but when it gets into business and things like that, there could be a new competitor arising who could give it too cheap. Okay, like maybe if I were to cite an example, what happened in telecommunication department once Geo came into picture, something like that. Okay, so I don't want to dig deeper, but yeah, so you should be very fair in whatever conclusions that you make, even if it adds profit. Okay, is it fair? Okay, so and then the confidentiality. Okay, so whatever data you store, you should store it in a very secure way. Okay, so you are storing some customers' data which should not be compromised at any point, and this is something that's very important. Okay, so if only data, okay, there is data that can be shared and cannot be shared. Okay, data that cannot be shared should not be shared. Okay, and then the accuracy. Okay, so whatever information that you generate, whatever analysis that you do, whatever results that it makes, okay, it is important that it is accurate. Okay, and accurate as well as in the same time it should be reliable. Okay, otherwise it's going to hurt your business. Okay, you cannot develop something that works only for today. Okay, so and let's say you analyze data only of a winter season. Okay, you develop something, you build a machine learning process analyzing data only of winter season. Okay, so the data that you analyzed only correspond to the winter season. And good thing is probably you deployed it in production at a winter season. Okay, but things might change when it becomes a summer. Okay, so you have to be very careful that there's a lot of analysis and checks that are made to ensure that this will suit under any circumstances. Okay, so that's why before doing any data science or machine learning works, they'll say at least have some years of data. Okay, don't do it on small data because it could be misleading. Okay, so accuracy is very, 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 very important. Okay, so transparency and yeah, so whatever you do, it should be, sometimes it's okay to tell the customer on how exactly you are going to use your data. Okay, so many people are doing it, that we are going to use this and to what I say, for these many purposes. So always okay, so it's pretty much like calling right to information, right? So what the government is doing, there's a right RTI Act where you are also allowed to know everything. Okay, so that transparency should be there with the business, customers, and all the stakeholders. Okay, so these are the best practices or standards that uh, everyone should understand. So data is I'd say it's a very big field. Okay, where it's not only the technical things. Okay, I think you must have got a understanding of it now. Okay, you should understand a lot apart from technical things, and it's always interesting. Okay, you understand the bigger picture of what's happening, and you know why exactly people are doing things. Okay, and that's where this field is very, 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 very exciting. Okay, for anyone. So yeah, that's all under this section. So are we good? Any questions? Okay. If there's nothing, then I will proceed. Okay. So here is the most important section for all of you, I would say. How is the career going to be like in data analytics? Okay. And please be more focused on this because this could definitely help you. So we saw different sections. In the top, you see the different use cases that we saw, analyzing the business problem, then sourcing, ingesting and storing data, and preparing the cleaning and normalizing data. Then you have to analyze data. Then there is some ML works, and you put it for people. Okay, and there is some visualizations and everything involved, and then it is in the actual business process. Okay, and these are the different roles that are involved. Okay, and you might be someone who is contributing in a single area, or you might be someone who is contributing in a bigger area. Okay, like some people are good at doing all these. Okay, some people are good at doing 2 or 3 things. Okay, but what works? Okay, so you can specifically look at certain things, and these are the different roles that are involved, starting from analyzing the business problem. Then there are business analysts or domain experts, and you must have heard about SMEs. Okay, subject matter experts, and um, subject matter expert related studies. There are short-term courses and stuff like that, and which are very playing a very crucial role nowadays. So example I can cite is there is something called actuarial science. I'm not sure how many of you have heard about it. every banking, insurance domain industries, they are sourcing a lot of people who has that knowledge, was done some course on actual science and things like that. So it's all about knowing the risks, okay, insurance risks, banking risks. So these people learn about all those things, which provide some expert knowledge, okay, and it's all based on the data in the background. Okay, so business analysts, domain experts, or subject matter experts, and then you have data engineers, a little bit technical. Okay, so who can source data from different places and put it together for um, further use. Okay, so that's where data data engineers, big data engineers, data analysts, okay, data quality analysts, okay, QA resources, and all these people come into picture. And then again, you have to clean the data. Okay, so that step is where you put it into data warehouse. Okay, so then you have ETL developers, ETL in the sense extract, transform, load developers. Again, big data and data engineers do all these works as well. Okay, so a lot of these overlap because they are closely related. And next thing what comes is the data analyst. Okay, so data analysts, they now have to analyze the data, how the data is distributed. Okay, so once you are a data analyst, you should have some statistical knowledge. Okay, you should be someone who loves numbers. Okay, you should have some statistical knowledge. And what you try to understand is different types of data. Okay, how is this data, how is it distributed? Okay, when this value is going up, whether the other is going up or not. Okay, is it directly proportional or indirectly proportional, or is it not having any relevance? Okay, so you do all those sort of analysis. Okay, and sometimes you do a little bit of data visualization as well. Okay, so that's the role of data analyst. Then you have data scientists. So these data scientists, data analysts, statistics, ML developers, all these roles overlap. Okay, but yeah, sometimes it's like, okay, you start as a data analyst and then you get promoted as a data scientist. Okay, so yeah, that's where, and again, you start as an ML developer and then you get promoted as a data scientist. So a lot of these roles you see here, they overlap. And then specifically into data science, that's where statisticians, ML developers, and data scientists, so they purely involve in statistical modeling. Okay, so where a lot of prediction in the background, it's all statistics in the behind predictive analytics. Okay, so there are some statisticians, ML developers who are involved, and then you have data scientists or ML developers. And I think that, okay, data visualization will also play a little bit of picture there, where you put it in front, okay, for people to see it. Okay, what are you predicted? This is what it is. Okay, so you deploy it and then it's used in business processes. Okay, so again, functional analyst and business analyst, again, that overlap. They are in different corners, but that again overlaps. Okay, so is it clear, or do you have any questions here? Anyone? But these are the different roles. These are the different roles um, that are in this space. Okay, so is it clear for everyone, or do you have any questions? If yes, then I'll address it. Okay, sounds good. And maybe this is the question. These are the questions that you have to ask yourself today. Okay, are you a good communicator? Okay, so um, you do all the technical works. Okay, but you should ask a lot of questions. Okay, so data, whatever data you project, okay, you make it it should, end of the day, make sense. Okay, so what do? You have to communicate efficiently so that you understand the requirement very well. So when you come into data space, you should understand things very well. So you should be a very good communicator. Okay. And can you narrate stories? Okay. Don't think it's about some fairy tales or anything like that, or you don't have to create any out of book stories. Um, let's say that you are someone who is analyzing the monthly sales of your company. Okay. So to the people who are in the management, right, you cannot tell all the functional aspects or technical aspects that are involved. Okay, you just have to tell them how it. You have to put it in a form of a story. Okay, no technical stuffs. You cannot tell that I used big data or ML. Okay, so you can always say that this is what it is and this is what I'm thinking. Okay, or this is what I see with the data. Okay, so you are someone who should be able to interpret this data all that you see in a form of a story. Okay, so that's the second thing. And third thing is, are you good at coding? Okay, so as computer science graduates, uh, any field you go, be good at coding. Okay, learn something or the other. Okay, so but again, here in this space, coding is knowledge is very, very important. Okay, where we should have a um, good technical knowledge. Okay, and one more thing I would insist is it's not like before. Okay, now there is a we can we can find a lot of people who are writing who are good at coding right when they complete their graduation. Okay, so now the competition is increasing than how it is before. And again, okay, so you are expected to be a multiplayer. Okay, so again, in organizations, you are expected to do multiple things. Okay, not really like you are expected to work more than time, but if you are someone who can contribute in a lot of areas, then that's where people find your value. Okay, so again, you should be good at coding. And then, are you someone who's fascinated with numbers? Okay, all that we saw here, all the examples, in the end, you should see some numbers. Okay, whether my business is growing up, going down. Okay, so whether this is something that's contributing, whether the increase in this number is contributing to my business, or whether whatever it is. Okay, so uh, it's all with numbers. Okay, in the end. Okay, maybe it doesn't start with a number in the beginning, but it always ends with some numbers. Okay, so maybe getting all these four, it's four simple state questions, looking at it in the front, but behind it there are a lot of things. Okay, so at least if you can master in two or three things here, okay, then it is great. Okay, so don't think that you can master in first two things and be an expert, but maybe I would say one in the first two and one in the next two. Okay, then you are good. Fascinated with the numbers, you might be good at mathematics, you can learn statistics. Then you're still in the loop with a little bit of coding knowledge. Okay, so these are questions that I would suggest you asking yourself today itself. Okay, so any questions? Are we good? Okay, sounds good. So some of the key skills, okay, that you can acquire. So there are a couple of things here: Python, Bash, which is the shell scripting, also called as Unix scripting, and Tableau, Informatica, Hadoop. Okay, so let me Python. Python is something that every data engineers or data analysts. Okay, so Python is something that you should learn for sure. Okay, um, because of the demand that it has in the market. If you're getting into data space, then close your eyes and learn Python. Okay, so and then Bash. Bash is like, okay, so most of the uh, most of the real applications, right? Actually, so it's not Windows applications that are mostly used. It's all Linux based applications, and to automate things, then you will be writing something in shell script again. you can still survive without knowing shell scripting, but it's always a good thing to know. Okay, so Tableau is for data visualization. Okay, so there is a student version and everything. You can download it, and there are a lot of tutorials too, free tutorials too. Okay, which you can where you can practice Tableau. And Informatica is licensed. It's a ETL tool used for loading data to data warehouse. Hadoop, again, it's open source, but it takes a little bit of infrastructure facility to set it up. And then you have cloud, AWS, Azure, or Google Cloud. So businesses are slowly moving into cloud. Not slowly, they are moving into cloud because of the increasing demand and the need to scale up. Okay. And Apache Spark, which again is on big data, and SQL. SQL is something that you can, okay, SQL is like the alphabets in IT industry. Okay, so if you don't know SQL, then you are like a native English speaker who cannot read or write English. Okay, so you are into IT, but if you don't know the alphabets, then it doesn't look nice. So that's how SQL is. Okay, it's the alphabets for in IT industry. So then Java is again something good to learn. And yeah, if you have Python, then okay, that's still okay. Okay, but if you know Java, then it's great. And then Scikit-Learn, it's something that's relevant to machine learning, and Kafka is a streaming application. So to pull data and bring data into real time. So among these, I would suggest if you're someone who is yet to start things, I would suggest you to start with Python and SQL, and then maybe slowly get into, okay, so if you are interested in data visualization, get into Tableau, and then it's all about what you want. If you want to learn cloud, then you choose cloud. Then if you want to learn big data, learn Hadoop and Spark. Okay, so I would say maybe start with SQL and Python if you want to start it new, completely new. Okay, so yeah, so I think we have come to the end. So this is Control for AI is something that I take a lot of pride in. This is one of the Python libraries for which I am the owner, and it's it's in use nowadays. It's largely used nowadays. Okay, there are some uses for it, and yeah, maybe if you're someone who is fascinated about machine learning and stuff like that, so this is really intended for the data pre-processing. And yeah, and I have done this work, so it's always feels good to share about it. So you can also take a look at it if you are good with Python, and if you have already started something in machine learning, maybe it's something that you can definitely check on how it works. Okay, and okay, so at last we have come to the end, and just adding some fun. So somewhere in near future, just look at the image, and I'm not going to, there's nothing much to explain here. So you can see it. Okay, so there is a robber, and he's coming and saying, keep the cash. We just need the credit card data. Okay, so data is maybe in sometime in near future, data might get a lot of value than the liquid cash itself. Okay, so yes, that's all I have. I think I completed well ahead of time. So maybe I can answer some of your questions.